Michaela's getting it for us.
Hello, we're here.
Hello. All right, so I'm going to get started because Stafford has to end promptly. So we're going to talk about ionic bonds today. We're going to start the conversation on how atoms of different elements of the same element react. Do you need something, Mr. Britt?
No, I was just telling my kids to be quiet and in my mind.
Okay. So here are some ionic compounds. What patterns do we notice? What do we see about how the compounds are written that give us, like, we see it happening over and over? They're what? Okay, so symbols are written correctly. Big letter, small letter. This is open for King George and Forge as well. So we have two elements, okay? So by default, for it to be a compound, it has to have it has to have more than one.
Tell them.
A metal plus a non-metal, good. I'm just making a list of what you're telling me. So we have a metal plus a non-metal. That's really important for ionic compounds.
They say the metal is first.
The metal is written first. Good observation. What else? What other things do we notice in the pattern? Anything? What do we think the numbers mean? Are they just there for fun? Like, just randomly you have to know that you have to add a Cl2 when you put it with magnesium. Yeah, so the subscripts represent how many that we have. Good. So those are all good patterns to notice. So an ionic compound, by definition, forms when an electron changes ownership. It changes residency, if you will, and it leaves the metal and goes to the non-metal. Okay? And so what we have in the context of an ionic compound is we have a transfer of electrons between atoms. Now, some terminology for you. When a metal loses an electron, electrons have negative charge, we know that. So if I give away negative charge, what's left behind is positive. That is a cation. Please say it correctly. It is not a cation. I know that that's how we would pronounce it, like vacation. I get that. But in the context of chemistry, it is a cation. Okay. When the nonmetals take electrons, they are going to form a negatively charged ion called an anion. Now, the goal of moving these electrons around is a complete octet. We want to have a full valence energy level. Okay? So that's the goal. The way we achieve the goal of that complete octet is that the electrons switch places. And you'll notice, because it's a metal and a non-metal, we're going to have a fairly large difference in electronegativity, which is that attraction for the electrons. Okay? So when we make an ionic compound, we have a cation and an anion. So we have a metal and a non-metal, one of the observations that you made. When we combine all of our ions together, we have to have a 0 overall charge. Okay? So when we combine all of the ions together, we get a 0 overall charge. That is really, really important. So here's how we do it. Okay, we're going to take the symbol and the charge for each ion. Okay, if you have the flow chart, maybe put some notes down on there on the back. We have, when we're all done, we have a 0 charge. Yeah. We're going to use the pattern from the periodic table of valence electrons to figure out what the charge is. So if I look at the periodic table, group 1, the alkali metals, all have how many valence electrons? 1. So it is a metal. It can give away 1 electron. So all of the alkali metals will have a charge of +1 when they bond. Does that make sense? They'll give away 1 electron. That's they won't give away non-valence electrons, only valence electrons. So just those S and P electrons that we learned about, only those ones are involved in the forming of these ionic compounds. Okay, that's not exactly true, but we're going to go with that. When we get into transition metals, it gets a little muddy. So then group 2, the alkaline earth metals, have how many valence electrons? 2. So what charge will they have? Someone out in Zoom world, if I have 2 electrons and I give them away, what charge is left? Say again. +2. Yeah. So we know how to find valence electrons, right? That's one of the trends we found on the periodic table. So the trends of the periodic table, group 1 have 1, group 2 have 2, group 13, 3, 14, 4, 15, 5, 16, 6, 17, 7. Do we have a non-metal? Do we have a metal? If we have a metal, it's going to be positive, whatever that number is. Does that make sense? If we have a non-metal, let's say I'm looking at oxygen. Oxygen is a non-metal, so it's going to take electrons. It wants to bring in more electrons to get to complete octet. Well, how many valence electrons does oxygen have? Someone out, let's see, Riverbend, how many valence electrons does oxygen have?
6.
It has 6. So how many does it need?
1, 2.
2. So it'll be a -2 because it takes in 2 extra electrons. That's how we figure out the charge. Does that make sense? And Any questions on how we figure out that charge? So what happens for the duet? So there's one element that's gonna do that, and that's hydrogen. Where is hydrogen on the periodic table? Which group? It's part of group 1, alkali metal. It's not really a metal, right? Hydrogen is that one element that kind of, sometimes it acts like a metal, sometimes it acts like a non-metal. And we'll know that based on whether it's written first or second. And I'll give you some examples in a minute. It has 1, so it's either going to be a +1 or a -1. Good question. Okay, once we know the charges, we can determine how many of each I need. So we're looking at like least common multiple. Does that make sense? If I have something that has a +2 and I'm trying to match it with a -3, how many of each do I need for it to end up as a 0? I have a +2 and a -3. So what's the number that 2 and 3 both go into? 6. How many 2s do I need? 3. How many 3s do I need? 2. Does that make sense? Because I have to have the same total positive, same total negative charge. All right. We're gonna do lots of practice. I'm just gonna give you the rules. We're gonna do lots of practice. I think most people find writing the formulas easier, but I want to give you all the rules, and then we're going to do practice on site. So here's the naming. I've given you several. Do we notice any patterns in the naming?
The metal comes first.
The metal comes first. Absolutely.
What?
They all end in I.
Most, that's a great observation. That's one I hadn't thought of before. Most of the metals end in UM. That's not always going to hold true though, because we have gold, we have silver, we have phosphorus. Phosphorus isn't a metal. Tungsten.
Like ending for the non-metal is some sort of like I.
So the ending for the non-metal is IDE. And we're looking at binary compounds. So we take and retain the root of the non-metal and add the suffix IDE. So what would we say is the name for I'll skip K. What's the name for Li? Lithium. What's the name for N? Nitrogen. So we take off the ending and we add IDE. So we take off the OGEN and we have nitride. Okay. You're going to get lots of practice, I promise. So the pattern, we're just going to do it. We have potassium bromide, lithium oxide. What would SR and SE be? Let's go to north. What would I name that? You're muted if you're trying to answer. I don't hear you. North. And if you can hear me, can you help me?
Yeah, sorry, they were thinking.
That's
You're
okay. We're allowed. All right, so let's do this. Let me find my. Hopefully you're now seeing my paper. Yes?
Yes,
Okay. So what is the name of this guy's north? Find it on the periodic table.
Oh, and then that's like this.
Mm-hmm.
Okay. What's the name of this one? Selenium? I drop I spelled it wrong. Selenium. Spelling is hard. Words are hard. I get it. There's a reason I'm not an English person. All right. I take off the ending and I add IDE. So this would be strontium selenide. Now let's write the formula for it. What's the charge of strontium? North, I'm still picking on you. Get your periodic tables out.
Mm-hmm.
2
But is it a positive or a negative 2?
plus.
Plus. Good. Selenium. That's
3.
way over in group 16. What charge?
Negative
Negative what?
3.
How many valence electrons does it have?
6.
6. It wants 8. So how many away?
2.
So if I have +2, minus 2, how many of those do I need to be balanced?
1.
I need 1 strontium and 1 selenium. So there's the correct name and the correct formula. Okay. So Riverbend, you're going to do RB and N. King George, you're going to do AL and F. Colonial Forge, Stafford, and who am I missing? North. Okay. I'll give you like, I don't know, a minute. Figure it out with your class and we're going to report back. All right, Riverbend, you're up. What do we get for RB and N? Name and formula, please.
Go ahead, Kaylee.
Rubidium nitride.
Okay, good. And what's
Anyone
the
work out the formula yet? Go ahead.
With the RB3 in one.
good? Rubidium is a +1, nitrogen is a -3. You can cross those over, bring them down. King George, what'd you get for these two, please?
All right, y'all. What's the first element?
Aluminum.
Okay,
Aluminium.
aluminium. That's the way my grandma
Phosphorus.
used to say it.
What? What's our second one?
Phosphorus.
What do we do with the ending?
Phosphorus.
Fine.
And what would the formula be?
All right. Where did aluminum fall on the periodic table? 3. 3, is it plus or minus? Plus 3. All right, what about P? Where'd P fall? Are you sure -3?
No, -1.
-1. -2. Y'all tell me, come on. 1 of A and 3 of P.
So Mr. Britt, if I could just follow the same pattern, how many valence electrons does phosphorus have?
How many valence electrons does phosphorus have?
3.
5.
It has 5. It wants 8. So how many does it need?
It needs 3.
So that's how you're going to figure out that negative charge. Okay. So your formula would be how many of each?
One of each.
One of each.
One of each. Good. All right, Forge, you're up. I think this is still aluminum.
You're up.
What's the name of this guy gonna be?
Oxide, she says.
Okay. And what will our formula be? Still gonna be +3. Al2O3. Good. All right, Stafford, what you got?
Iodide. CaI.
I would encourage you to write your capital I's with, what do they call that in kindergarten? Hat and shoes? Because if I write it like this, sometimes people confuse that with a lowercase l. So I would just encourage you to put the horizontal lines on your I. You don't have to, but I think it will help you keep from some confusion later. All right, North, how about BA and N?
All right, go ahead, guys.
Barium nitride.
Okay. And the formula, please.
BA3N2.
We got this, right? Just making sense? What questions do we have? Okay, so let's fill in our flow chart. We're gonna come back. We won't get through all of the flow chart. Your teachers will pick up with Roman numerals next time. Guys,
Yes.
so the first thing we want to ask is it binary? Binary means 2 elements, just 2. Yes or no? It's a cut and dry answer. And so in that box of your flow chart, the top one, is it binary? Yes or no? Okay. We're going to focus on the yes part for today. If it is binary, we are going to add IDE to the ending of the anion. Okay. That actually will be true for covalent compounds as well. The most dangerous one we know, most dangerous molecule we know, dihydrogen monoxide. You guys know that one?
It's called water.
It's called water. If it's too hot, it burns you. If it's too cold, it burns you. Too much of it in the wrong spot drowns you. It's an old joke. There are people there. This is why you have to be an informed consumer, because people will say, oh, dihydrogen monoxide is so dangerous. And you'll give them all the facts, like it can burn you, it can drown you, it can, if you don't have enough of it, then you dehydrate and die. And people get all riled up about it. And then you find out it's water. And oh, I feel that was a trick question. So we want to use ID at the end of the anion. Sorry, I digress. Is a metal present? Yes or no? Do we have a metal? How do we know we have a metal? Periodic table, right? Based on where it's located. If it's to the left of the staircase, then we have a metal. If a metal is not present, that's covalent compounds. We're going to talk about that next. So we're just going to hold that thought. We're going to chase this yes part. Okay. Does the metal form only one possible cation? And here's how we know that that is true. Group 1, alkali metals, always form a +1. Group 2, always form a +2. We're good. The rest of the metals, most of them actually form more than one possibility, and it has to do with partially filled D suborbitals and partially filled F. And so it is easier for me to tell you which ones to memorize that are one metal than for me to have you memorize all the rest. Does that make sense? So here's the list to memorize. It's written there for you. You want to copy it down. This would be a great unit for you to make flashcards. Okay. Silver will 100% of the time be +1 for our purposes. Cadmium and zinc +2. Aluminum, gallium, scandium, yttrium +3. Zirconium and titanium +4. Now, depending on which book you're looking at, some change the list slightly. I'm using the one from our reference OpenStax. This is the ones that they say are only going to form this cation. And you know, your teachers may say, oh, no, I want you to learn this one or that one or change the list, and that's okay. I pulled the list from the textbook. We do have a textbook. Okay, so we have 9 that we have to memorize, 2 columns we know the pattern of, and then all of the rest of them fall into the category that they'll make more than one cation, and we're going to deal with those next time. We don't want to get confused on that. Okay. So if the metal only forms one cation, then the element name is the element name, and we're going to write it as the metal, then the nonmetal. So we change the ending of the nonmetal, we keep the name of the metal, put them together. We do not use Roman numerals for group 1, group 2, and those 9 elements. All the rest of them will get Roman numerals, and we'll teach you how to figure that out next class. Or maybe at the end of class. Like Stafford County, we get 20 minutes before broadcast, and Spotsy, King George get time after. So your teacher's going to do the no parts with you because it's easier to do on site than in a Zoom. Do you have any questions? That's where I'm going to stop for today. Teachers, feel free to move on with the no parts of things. And if there are no questions, we will call it a day, and we will see you next time.
Thank you very much.
Thank you.
There we go. Bye, 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 bye.
Bye.
Bye.